phishing detection, despite the fact that large language models exist, doesn't seem to work very well.
Yep.
Constantly flagging the wrong things. We've got so much more to do in this area. And actually, I'm also, as an aside, a big fan of learning about more than one topic, because I think it gives you that broad experience of how this might apply. Just knowing how to train a deep network, but no knowledge of who could use it or how it might apply to something like cybersecurity is going to be limiting. You want to try and just know a little bit about how other things work as well. It was such an obvious pushback from someone like me or someone like you, and yet Microsoft just didn't seem to see that coming. Like, that we wouldn't want to just take all our desktop screenshots and just throw them straight up to a server. I think there's a lot of privacy concerns, and I don't think they've been adequately addressed necessarily.
No. Hey everyone, it's David Bombal back with the amazing Dr. Mike Pound. Mike, welcome.
Thanks for having me back.
Really important topic, I think. It's 2025, and I've written this question down for you to answer, please. How would I learn AI in 2025 if I was starting over? But perhaps before we get there, you could just give us perhaps an update of the state of AI. I've heard all kinds of things, but perhaps you could tell us, is it worth me learning AI? What's the state of AI?
It's still worth learning. It's not gone away, put it that way. I think my take is this year has been the year of starting to build systems with AI, right? So we had an era, let's say from about 2022, 23, 24, where we were focusing very much on just making the language models bigger.
Yeah.
And the idea was, well, sooner or later, they'll just start solving all the problems. And that hasn't been the case, as many people kind of thought anyway. And so now what these companies are doing is building slightly smarter systems with what we call things like retrieval augmented generation, bringing data in to the language model to make it more accurate, and combining language models together. So have it draw images, but also write text, letting it use tools, right? So go off for the weather and actually get a data source rather than just kind of making up a weather forecast. And so I think that what's changed in the last year is that kind of the way that we're designing systems is moving towards building LLMs and other AI into tools that do other things as well to make them more performant overall. And that's a really exciting time because these things are just working much better now that we have actual data being put into them.
Is it hype or is it getting real? Because I've heard like Sam say that AGI is coming in like 1,000 days or a few thousand days.
He likes to say that. I think that Sam says that. I don't know whether Sam actually believes that or whether he says it because it helps OpenAI's stock price. I don't know, honestly. I don't think that. And I think quite a lot of researchers agree with me. I would like to think so. That's the opinion I see when I read around. I think that the fact that we've seen this move over to trying to build and use LLMs as tools as part of a larger system is kind of an admission, in a way, that they're not just going to solve everything on their own, and that the ultimate solution may be one that uses some of these technologies within other things as well. I kind of feel like they're really, really cool. They work really, really well at what they're specifically trained to do. And so use them for that purpose. Don't try and just start assuming that we can just stick a chatbot in a car and off it drives. It doesn't work that way.
Do you call it math or do you call it maths? Is it aluminum or aluminium? Doesn't really matter. From a maths point of view, the great thing is that Brilliant can help you understand the mystery and depths of mathematics. With Brilliant, you can turn your confusion into confidence step by step. You're going to learn so much more by doing, and that's where Brilliant really shines. Rather than you just passively watching someone lecture you, you're going to be solving problems. You are going to be answering questions and quizzes. Brilliant makes learning to code intuitive and fun with lots of hands-on interactive quizzes and labs. Brilliant breaks down math concepts visually, so you're not just memorizing, you're actually understanding what you're doing. Build formulas, solve real-world problems, and challenge yourself every step of the way. Whether you're brushing up on mathematics fundamentals or tackling advanced topics like calculus, Brilliant has a course for you. I recommend that you check out their Vectors course. They make even abstract concepts easier to understand with their simple interactive examples. Try Brilliant for free for 30 days. Go to brilliant.org/David Bombal. Plus you get 20% off your annual premium subscription. Learn something new every day and change your life. When you spoke to me a year ago, you were talking about, the AI people are hyping it that it's going to be exponential. And then 7 months ago, I saw also on the computerphile channel, you mentioned you looked at this white paper where it was plateauing. So, what's your opinion now? Is AI going to suddenly be exponential again, or is it plateau, or is it somewhere in the middle?
I don't think anything has changed from that. I think that this sort of exponential, or should we say logarithmic, actually, probably, trend is still happening, right? GPT-5 hasn't been released with some massive increase in performance. What we've seen things like O1, which introduces slightly different ways of using these models, but the actual model itself is kind of the same as it was before. There's been another really interesting paper recently by Apple, actually, that showed that you can really easily confuse language models by giving them extra information. So suppose you're asking a question like a mathematical question, like you've got 5 watermelons and you have another 3 watermelons. How many watermelons do you have in total? Large language models do really well at this task. And the assumption has always been that it's because they just know how to add up. Right, which is not really the case. What this paper did so beautifully was they just created variants of all these questions with superfluous nonsense information in. So they'd say things like, how many, I've got 5 watermelons that are really small, by the way, and I've got another 3 watermelons. How many do I have in total? And the LLM will just completely break. It will just say, oh, because they're so small, you only have 3, and it just won't work. And it's because they're not trained on that kind of data, and they don't actually reason their way through a problem as we might see that they think that they do based on the text. So I think that using them in a smarter way is the way forward. And actually you can see that's what O1 is, right? It's using an LLM in a way where it sort of has this monologue with itself, which is a way of coercing better results out without having to transform the way the model performs.
Are we in the middle of a hype cycle? Because every vendor and everyone seems to have like AI as a product. Everything is this plus AI. It feels like it's just hype.
Yeah, I mean, we had the new iPhone came out quite fairly recently, and all of the stuff was about AI basically. And the difference, it seemed to me, between the 15 and the 16 was the introduction of AI.
Yeah,
we very much are in a hype cycle in the sense that I think companies now feel that they have to introduce these features as a way to compete in a market where everyone else is already doing this. And actually, when you use these features, I mean, everyone's mileage may vary, right? Other people might really love some of these features, but I kind of find they work some of the time, and other times they don't work. Yeah. Yes, I could ask my phone to rewrite my text message, but I actually just wrote the text message and I'm going to kind of just send it. Yeah. So I'm not flippant. I think some of these things are really good, but I think that we shouldn't be throwing AI at something just to say that we have, right? Which I think is what's happening at the moment.
AI on routers and switches and firewalls, it just seems to be everywhere.
Yeah, it's everywhere. Right, yes, and next generation, firewalls and all these things that include machine learning. Yep. I can understand why they do that, and maybe they perform way better. I guess I'd be more interested in the metrics, right? Does it actually find these things than kind of what it says on the tin? I think that we're going to see this for a while, but as people get more used to what AI does and what AI doesn't do, I hope and I predict that the sort of the hype will die down a bit as people kind of recognize, just because you've written AI doesn't make this thing good. Let's see if it's actually good and then just use it.
So coming back to the original question, how would you get started? First question is it too late? And should I get into this now? Or, have I missed the boat?
No, not at all. It's not too late. I think, I'll give you an example. I trained some large language models using an efficient technique just a few months ago.
Yeah.
Mostly just to learn how to do it, because I didn't know how to do it. I don't use large language models most of the time. I use vision models. Yeah. And I thought, well, let's add another string to my bow, or whatever the phrase is. And so I went off and I trained it. And it took me a few hours to kind of look through the code, work out what was going on, get something training. Yes, I have some expertise, but ultimately it's mostly just Python code, right? So actually, I think you can pick these things up pretty quickly. And the other thing is that the technology is moving unbelievably fast, and that's both good and bad, right? It can give you the impression that you're going to be left behind, but actually what it means is everyone's just having to relearn everything every 6 months anyway. It's a bit like JavaScript libraries, isn't it? So, in a way, I think that it's actually a benefit for people coming on board that a lot of what we're doing now isn't what we were doing 2 years ago, because it allows you to go, right, we'll just pick up what we're doing now and let's go with that.
So not too late, but what should I do then? What would you do now if you started again in 2025?
Yeah, so I mean, let's think about where people would be, right? So if you're an undergraduate and you've been working in the industry and you know how to code already, then the best thing you can do is take a very quick introductory machine learning course, get that done, and then just start playing around and trying these things out. Particularly with things like Google Colab, loads of big libraries that do things like retraining large language models. They come with Google Colab or other examples that you can literally just run. So the first time you run it, it's a complete black box to you. You don't know what's going on. You just click play and it runs and you're like, oh, I'm training something. This is great, And then you start to delve into it a bit and you slowly start to realize what's going on. You start opening that box. If you already know how to code, for example, in Python, then I think the best and quickest way is just to basically jump right in and start training some stuff up. Even though the first time you train it, you're going to feel out of your depth. You're going to feel like you don't know what's quite going on. And then over time, you will start to pick this up pretty quickly.
Do you have a course or do you recommend courses?
So I always still recommend Andrew Ng's Coursera course for machine learning, because I'm a sort of a firm believer in the idea that if you know how machine learning works, which is to say things like what does a learning rate do? What should a loss function do? Then the rest of it kind of comes out in the wash, right? Yeah. Large language models sound fancy, but they're just big versions of the kind of same networks that were being trained many years ago. And they train in exactly the same way, which is to say you have a loss and it goes down as you get better at predicting your outputs. And if you know how to interpret that, if you know how to look at those numbers and go, right, this is what I should do next, that's going to put you in a really good position. If you jump in and run the code, then you'll see this loss going down, and that's great. But then when it doesn't go down, you won't know quite what to do. And that's, I think, where a little bit of the fundamentals will help. Right? And you can do these things kind of at the same time. So, there are different levels of machine learning. So there's sort of what we will call maybe sort of standard machine learning or classical machine learning. These are things like support vector machines and small artificial neural networks. These are the kind of topics that are covered in things like Andrew Ng's Coursera course. And above them, you've got the kind of convolutional networks and the vision networks and then transformers. And then above there you've got the really big large language models. And they're a progression. If you understand what one does, it's kind of a level of abstraction. You can understand what the next will do and what the next will do. And the leap isn't as big, going upwards. Almost all of my research is AI driven now.
Interesting.
I do sometimes do traditional computer vision, which is to say, manipulate pixels basically. And I can still do that. And I sometimes force myself to do it just to remember how to do it. But actually, often, a lot of the time, someone will present me with a problem and my first response will be, well, we probably need to train a deep network to solve that problem. It's both true that we are in a hype cycle, but also true that these are incredibly performant techniques and knowing how to use them is going to help. Getting the first ones trained, that's not a big ask. It sounds really hard. It sounds intimidating, but I kind of feel like that's a bit gatekeeping, right? It's a bit people saying, this is super hard. Look how smart I am.
Yeah, exactly.
I don't like that approach, right? I prefer the approach of saying, look, they develop these libraries to make them easier to use, specifically so that you can have a go and use them. Right? And then if you're willing to kind of get a little bit stuck in, one of the things that I did when I was learning how to train large language models was I looked at the data. I actually looked at the rows of data that were going into the model to see how they were structured, how they shaped that data that the large language model could use. And that allowed me to shape my own data to reflect that, and then I could train on my task. So a lot of the time you're kind of learning by seeing what's been done before and kind of manipulating that into something that works for you and then going again. And then once you know how to interpret the results, then you're all good.
I'm glad you mentioned gatekeeping, because it feels like unless I've got a PhD or I really know maths very well, or all this like data science stuff, I've got no hope.
I'm a firm believer in an undergraduate degree as well, right?
Yeah, sure.
But it serves a slightly different purpose. There are loads of benefits to going to a university to study computer science for 3 years, and that's all you study, because you learn a huge broad range of topics. AI is only a very small part of what you learn at an undergraduate degree. You'll also learn, how firewalls work, right? And how object-oriented programming is done. If you already know some of those things, then actually a degree is only going to have a very small part, right? Maybe a master's might be more targeted. But actually, I think that for people who know what they're doing, for people who've already got a degree, it isn't reasonable really for you to go back and pay again all those fees to learn a second time. That's when you use the skills you've got already. The fact that you know how to work independently, you can learn on your own, you're willing to have a go, those things are going to help. And there's loads and loads of resources online.
So learn Python, that's the first step, right?
That's 100% the first step. For better or worse, Python has kind of emerged as the language of choice for most machine learning. That's true of pretty much most, any type of machine learning. Lots of people work in other languages like MATLAB and C and things like this. For the most part, people work in Python. All of the big libraries, so things like PyTorch, and large language model libraries like Unsloth that we can talk about later, those are all based around Python. They all operate in a similar way. And so you very quickly get used to how this works and the ins and outs. Learning Python is the first thing to do. And I would say also that Python has a lot of very advanced language features that hardly ever come up. Right? You might see a function call that uses some strange Lambda expression you're not expecting.
Yeah.
But in general, that doesn't happen. And actually kind of standard Python will get you through most of the day.
So Python, then Andrew's course on Coursera, and then?
Yeah, so I mean, there are going to be lots of courses. So if you're on, a different platform like Udemy or something like that, there will be perfectly good introduction to machine learning courses. I would advocate not getting too overexcited and jumping straight to the large language model on day one, because if you do that, it will be a black box for you. It's going to be something where you're training or using a very, very large model that you don't understand. And that's fine. You can build a product based on that. It's what a lot of startups do.
Yep.
But you will be able to use it better if you have a little bit of an understanding of what's going on underneath. And to do that, you need to build up a little bit from the ground up. And it doesn't take that long. We have undergraduates who start projects and they haven't got any AI background particularly, and they're training things up within a few weeks, right? To the point where they actually know what's going on, right? It does require some effort. It's not something where you can just go on GitHub, go to the collab, run it, and then consider that problem solved. You are going to have to look into these things.
Python, Andrew's course, or some other courses, anything after that? Do I need to buy books? Or
there are loads and loads of books on machine learning, and I wouldn't necessarily say that's a bad thing to do. I think one of the problems is because everything moves so quickly, those books, it's going to be difficult to have books that are on the cutting edge version of some library you're trying to use. And so I found my personal experiences of learning some of these techniques is just to run them. Like I say, the first time you run them, they're hard, and then they get a bit easier and they get a bit easier until, okay, this is pretty routine. Most of the big libraries have tutorials, and they're not all great, to be fair, so I think your mileage may vary. But I would say that the other thing you can do, and this is a bit like learning to code, right? If you want to learn to code, I've always thought that the best thing to do is just to do lots of coding, right? It's not something where, yes, you can be taught concepts, you can be taught, about conditions and Booleans and things like this. But ultimately, when you spend time just answering questions and solving problems using code, you get better and better at doing it. And I think that's very similar also with machine learning. If you train up a simple classifier and then you go on to a more complicated topic and so on and so forth, that's kind of a nice progression. So maybe we can talk a bit about that progression, right?
That'd be great, yeah.
If you do something like Andrew Ng's course, you'll find yourself, pretty well versed in kind of low-level standard machine learning, which is to say things like support vector machines and neural networks. The next thing perhaps to do would be to look into something like a convolutional neural network, or maybe a transformer, but they're a little bit of a step up, or at least they're a little bit different, conceptually different. There are, thousands of collabs or GitHubs that show you how to train a standard convolutional network from scratch. The PyTorch examples are perfectly good for doing this. You can just run them and they'll just classify some stuff and they'll download the data set for you. They'll classify some stuff and they'll learn, and you can sort of watch the numbers go down, and then you can go into the code and go, right, how did that actually happen? And then you can start to build up the complexity. If your aim is to go very much down the sort of modern generative AI route, so the kind of LLM route, then at some point you'll need to start making use of some of those tools. And so those would be things, libraries I quite like, so things like LangChain. So LangChain is good for putting models together into kind of working systems. And then you've got things like Unsloth, which is really good for fine-tuning large language models, which are pretty prohibitively costly to tune normally. And so, there's lots of these libraries, and they all come with, pretty good documentation and examples that you could actually run.
Do you have to pay a lot of money to run this stuff, or is a lot of it free?
No, you can. I think some of them have like a kind of commercial tier, but everything that I've used so far has been, either, free license. And I think that's fine. You can make a decision later whether something requires a little bit of payment. So, Google Colab is a good example, right? Google Colab runs essentially a notebook, a Python notebook. A notebook, for those people who are not familiar with Python, is essentially, instead of having one code file, you have kind of blocks of code interspersed with images and text and other bits of information. They can be very useful for documenting, but also looking at the output as you go. And you can also run these things in different orders. So you can say, well, okay, I want to go back and run that bit, see what the output is, and then run something else and see what changes. Google Colab is that, but a little bit posher, shall we say, and also backed by Google's GPU environment. So you basically got the ability to actually train models on these without it being really, really slow. If you want to do more than kind of token training, it's going to need you to pay some kind of £9 a month monthly fee. Else you're going to be waiting for a few hours for a GPU to free up, right? And so you can make that call at the time. Certainly, you don't need to pay to begin with. You can just get started, run a few things, try them out, see how you're getting on. And if you think, okay, I actually need to train this thing for a few days now to see whether it works, that's when you could consider investing in some resources.
We often do this like list of top skills for 2025. And on our list, AI is number one of the skills that people need to learn. Do you agree with that?
Yeah, well, I mean, I work in AI. AI, so I may be a cheat. I think there's kind of two answers to that question. So one is yes, I think that AI is the thing that's most people are discussing. I mean, at the university, I get emailed a lot from people who want to do some AI with their research. They don't have that background. They want to know how to get started. So I actually get these questions quite a lot. Which is great for me, right? So I get a lot of great contact with loads of cool collaborators in different areas of science. There's no doubt that people want to learn more. They don't just want to have me do it. They want to also have a go themselves.
Yeah, sure.
And so, when we asked recently lots and lots of academics, what would you like for us to do? The first response was, is there some training we can use? Can we put out some training on this around the university to try and get people skilled up? And I think that's going to be a really important thing over the next few years. I mean, I'll be thinking about this as well, what I can offer.
We need you to make a course, Mike.
Right, I know. Yeah, I'm sure you said this last year, and I've been stuck in meetings. But yeah, I think that I mean, there are loads of good courses. I think that the difficulty is, of course, which to pick. Right? Yeah. I think that's always the thing. I would not worry too much about that, right? Any content you're consuming that's explaining how deep networks work and how you train them is going to get you closer to that goal of knowing how it works. And then just training it yourself is also going to get you slightly closer to that goal. The only thing I would discourage people from doing is just run a notebook, press play all the way down to the bottom, and then kind of go to bed satisfied that you've learned some machine learning today. Because, if you've got to read the code, right? Read the code, see what it's doing. And then, hopefully you've learned a little something.
Yeah, Mike, the reason I asked you this is Dave Kennedy, who's really well known in the cybersecurity space, put out a tweet in early December 2024, and he said, cybersecurity automation with AI, LLMs, is starting to become and will be one of the most desired skill sets in the next 3 to 5 years in all of security. I mean, I'm assuming you agree with that because you nodded, right?
Yeah, so I mean, it helps also. So I'm an interestingly placed researcher because I research computer vision and AI. I also have taught security and cryptography for many years. So I have at least a pretty good knowledge of that subject, even though it's not my main area of work. And I would say that they're both incredibly hot topics, right? I mean, security of networks and the internet is getting more and more important. Yeah. In some ways, I always feel like we've got it so good now. We have encryption on every channel, but ultimately, actually, we also have huge state actors trying to get at our stuff. Yeah. People get phished all the time. Phishing detection, despite the fact that large language models exist, doesn't seem to work very well. Yep. Constantly flagging the wrong things. We've got so much more to do in this area. I think that is a very useful thing to know about. And actually, I'm also, as an aside, a big fan of learning about more than one topic because I think it gives you that broad experience of how this might apply. Just knowing how to train a deep network, but no knowledge of who could use it or how it might apply to something like cybersecurity is going to be limiting. You want to try and just know a little bit about how things work as well.
Yes, I mean, that example from Dave Kennedy, someone who's very well known in the industry, years and years of experience, and owns a cybersecurity company and does a whole bunch of things. I think if someone in the field says that, and someone like you doing a lot of research says the same thing, that's a real indication to anyone who's younger or wanting to change career or help themselves, better themselves, that they should learn this. The reason I asked, should I learn it, is cybersecurity, definitely need to learn AI. Other niches or fields, the same thing applies, right?
Everyone is trying to build AI into almost everything. Right? Yeah. Now, sometimes that's a silly idea. Sometimes this thing already works without AI and we didn't need AI and it's just making it more complicated. But on the other hand, there are lots of times where automation or just doing something you don't want to have to do yourself, AI fits right in there. And that's a huge amount of the work we do every day. I think that knowing how to do these things is going to be a real bonus for, even if you end up not directly researching or working in AI, just using that AI in other areas. We already know that one of the Nobel Prizes went for protein folding, right, which is an application of AI to a completely different area of science. That area of science will be completely transformed by that field, even if that AI isn't AGI or isn't superhuman and can't seem to drive a car straight. it's still on that particular task has been pretty transformative. And so I think we're going to see a lot of that. We're going to see a lot of places where there's been an absence of AI and suddenly it comes in and just starts solving problems that people assumed were not solvable, and so had kind of given up.
I love what you said, though. I mean, two fields that I really find interesting is cybersecurity. Obviously, I have like other loves like networking, but like if you were starting today, cyber plus AI seems to be an amazing combination.
It's a great combination. And they're also both really interesting, right?
Yeah.
So I find most of computer science interesting. Not all of it, I would say. But if you find something interesting and you're passionate about it, it's so much easier to learn as well. So if you enjoy the fact, you know what, this network is training, I can't believe it. It's actually doing that thing I asked it to do. Or I've installed this software and now this network is working so much better than it was before. These kind of, if you're pleased about that kind of stuff, you're just the right person to take on this kind of challenge and learn and just go off and learn all this stuff. I mean, I'm always trying to learn new things all the time, and I probably should just take a break and have a nap. But I think, I could learn about this, and I go off and I learn about it, and it's so exciting. And AI and cybersecurity are those two topics for me. They change so much. There's so much interesting news. Weeks don't go by without something cool happening in cybersecurity, right? And I think AI is just going to make that more exciting as well.
I love that. I think if I was starting again, and this is what I'd advise myself, and it's you seem to be saying the same thing. Get into cyber, get into AI. Two big fields, lots of potential. What you learn today isn't going to be lost tomorrow, is it? It's going to last you for the rest of your life.
Yeah, and also don't overestimate the level of AI that's required for a lot of the platforms that we see, right? Yes, training up something like Sora is a challenge and requires someone probably who's done many years of training these models at scale. Training a network to solve some task you had or to write some of your emails for you, that doesn't take as much expertise. It just takes a little bit of knowledge. And so you don't have to start with the big one. You can work your way up. And actually, there are loads of roles for people who are just doing kind of around the edge, not quite so fundamental, research or development in AI, which I think that we need a lot of those people as well.
It seems like the world's going to be split into two groups, right? Those who have the power of AI behind them, and those who don't have that, and they're going to be left behind, it seems.
As I say, there are going to be some situations where people are putting AI on a problem where actually they would have been fine, right? And I think we can all recognize that. I'll give you an example. Just for fun, a few weeks ago I trained. So the reason I trained a large language model was I trained it to write my emails for me.
Oh, right? Nice.
So I downloaded all of my emails. It turns out I send quite a lot of emails.
I can imagine.
And what I did was I gave a large language model a task. I said, right, here's an input email I received. This is what I wrote. Learn to do that for me. And it did it, right? Now, it did it with a few caveats, I should say. It wrote emails exactly as I write them. Because one of my bugbears with something like ChatGPT is it doesn't write like I write. I have a quite specific style. It writes much longer and more fluffy, shall we say, sentences than I would write. Everyone would know immediately it wasn't from me. Right. Yeah. So if I want to sort of actually take a holiday and not send my own emails, I'm going to need to cover up much better than that. So what I did was I trained this thing, and it wrote emails exactly as I would phrase them, signed exactly as I would phrase them. The only problem was it made up the answers still. Yep. So it would say something like, absolutely, I can mark your courseworks for you. Please just send them over. I'd be happy to do it. And I'd never send that to anyone. So, built into a system where it's prompted with some of this sort of my actual calendar information, or what my actual response roughly would be. So I can imagine a situation where I'm writing an email and I just give it a bullet point that says, this is roughly what I want to say. And it just turns it into an email fully fledged. That kind of thing would be transformative for my work, right? Yeah. Because I just spend a lot of time typing out words that could have been more easily done some other way. Yeah. When in fact there was just one key message I needed to get across, and the rest of it was just completely superfluous. Those kind of examples, I think those are the ones where AI is really going to help. We aren't there yet because everyone's just trying to interface with ChatGPT as it is, and that makes it kind of everyone just writes the same kind of waffly text. But I think as these tools start to become a bit more bespoke and a bit more tailored to an individual, that's when I think we're really onto something. Being part of that wave and knowing how those techniques work is only going to help you deploy those systems to yourself. You can deploy everything I did locally on my own machine, just to kind of prove a point. And you can deploy these things on your own PC if you want. You can have Llama, which is Meta's large language model, runs perfectly happily on a mid-range graphics card. a little bit more happily on a big graphics card. Sure. But you can train it, you can talk to it, you can coerce it into solving tasks for you, and you can do all of that locally at just the cost of the hardware, the initial investment in the hardware.
The world's going to change with people who leverage AI, just like people have the advantage of a phone versus people who don't, like an iPhone or an Android phone. It gives you such an advantage in life.
I don't want to give away how old I am, but I remember when the iPhone came out, and of course there were people who said, I don't need this nonsense, right? I'm happy with my Nokia. And well, what happened there, right? Ultimately, people went, hang on a minute, this is better. As I say, I think we're in for a couple of years or a few years of kind of not finding our feet, of learning what's actually useful and what's just a fun aside before we settle down to go, okay, this works, let's use this. And this didn't work. I mean, one of the things that I found really useful is I don't really use AI to code. Now, partly because I don't write as much code as I used to, because unfortunately I have lots of meetings to go to. But what I do find it useful for is zeroing in on a bit of the documentation I need to see in order to write that code. So when I trained this large language model, and I was using LangChain to do some retrieval augmented generation, and I didn't know how to do a certain thing, I asked it, which function in LangChain would do this. And within about 5 seconds, I was off in the documentation in the right place. Nice. It didn't write me good code that would have solved the problem, but it did point me to where I needed to read to then write the code myself within a few minutes. So I found it was a really nice productivity tool, but just as a kind of guide to just get me a little bit closer to this problem, rather than just trying to solve the whole problem end to end, which I think is where people assume AI will be useful. If you know about AI, you're going to be able to use it in little ways dotted around your work, rather than you just won't go to work and then AI will do it, which I just don't see as very plausible. So I think it's not going to have quite the impact people think. It's going to be different, but I think it will be nonetheless really, 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 really big.
It's interesting. The flip side of that is what a lot of people hate, and I find it really irritating, is when you do Google searches or whichever search engine, then it's got the AI answers at the top, and it's like, the information's not even correct.
Which is interesting, right? Because that's retrieval augmented generation. So to give you a definition, retrieval augmented generation, or RAG, is this technique where you inject live data into the prompt to help the LLM write correct text. That assumes that, first of all, what you've injected is correct. It assumes that you've injected something useful, and it assumes that that the LLM can correctly interpret what you've injected to answer the question. And it has the same issues that I think other large language models have. So I don't know if you ever noticed this when you talk to something like ChatGPT, you say something along the lines of, why is it that this happens? Yeah. But the thing you say is completely nonsense. Yeah. And then it gives you a proper description. Oh, that happens because of this, right? And it's because your question was wrong. Your question said, so you might say, why is the sky green in the mornings? And sometimes it will say the sky isn't green in the mornings, but sometimes it will give you an explanation as to why the sky is green. I mean, they're getting better for this, but they still will do it. The point, I guess, is because the question that was asked wasn't quite phrased correctly, it just ran with it, right? And you don't want your search engine just doing that and running with it, I think. And so we're in this bit now where it's been shipped as a product, but we haven't quite got a way of, is what they've asked actually something we can actually answer, right? Is the source we found to answer it actually correct? And has the LLM converted that text properly into a response?
Microsoft Recall sounded like a good idea to some people, but there was a lot of pushback about it. Real worry about AI and privacy. What's your point of view on that?
I thought it was fascinating that it was such an obvious pushback from someone like me or someone like you, and yet Microsoft just didn't seem to see that coming. Right? That we wouldn't want to just take all our desktop screenshots and just throw them straight up to a server. I think there's a lot of privacy concerns, and I don't think they've been adequately addressed necessarily. No. And I think companies are going to have to start thinking a lot more carefully about this. I don't think everyone is just intuitively happy with just, here's all my data, please upload this to a language model and do what you want, particularly because a lot of these companies have very vague information on what your data is going to be used to train on and stuff like this. So, look, do I mind if Windows does character recognition on my documents? Not particularly, although some of my documents are, confidential student marks and records. So, there's that. But do I want them being used to train a language model? Absolutely not, right? Because it's confidential. So that hasn't been solved. I think we need to think about that a lot harder.
Yeah, I mean, Adobe in their terms and conditions just like hid some stuff in there that suddenly anything you create can be used for the AI. It's like huge intrusion.
Yeah, and on X, right, or Twitter, as I like to call it, the terms and conditions changed recently to allow training on tweets, and that wasn't there before. And so you kind of got the rug pulled out, right? You're under the impression that it's not going to be used a certain way, and then suddenly it's sort of, and at that point you're already using the platform and it's difficult to disengage. I think it's a bit of bait and switch, right? Be careful doing this.
Yeah, and I think it like Apple even though Apple say they're a privacy company, so-called, a lot of people would push back against that. But like the chips directly in the phones, right?
Yeah, if the chip's in the phone, then I suppose theoretically that's a good thing, right? It stays on the device. And actually, I train a lot of my language models and stuff on my personal computer, specifically because I want to see what I can. And also, I think if there's a strong privacy reason for doing this. For people that are using data and are not sure about whether they should be uploading that to the cloud, the obvious solution is don't do that and just use it locally. I think keeping it on the device is great. I think Apple's policy is if the phone can't do it, it's going to go up to the cloud and it's secure, and they've got all these white papers and stuff just describing how secure it is. Time will tell. I think they are at least trying to answer the question a little bit, which I think is more than some of these companies are doing.
Mike, what's the difference between a GPU, MPU, TPU, CPU? Why do I care?
Mostly, I think it's just names people give things to sound good, right? So a GPU is the hardware in our computers usually that we associate with playing video games. So they were developed as a way of having many, many cores doing small vertex and shader tasks in parallel all at the same time really, really quickly. Ultimately, AI actually just boils down to mathematics. And what it usually is large multiplications. So basically, you have an array of numbers, let's say 2000 by 2000. You have another huge matrix of numbers. You have to multiply those two things together. And that actually isn't that difficult. It just takes a long time. And it's something that can very easily be done in parallel if you have a lot of cores, which is what a GPU has. A TPU, or a tensor processing unit, is just hardware specifically designed to do that. And that's what Google call it. An NPU will depend on what company you're talking to. It's called like a neural processing unit. But for example, the NPU, or the equivalent in the new iPhone, is essentially a part of their chip that is responsible for crunching these numbers really, really quickly and allows them to deploy these models. So you can imagine an idea where Apple will train a model behind the scenes on all their data. They will then freeze that model as it is, and then they will deploy it onto a device. And the NPU is the thing that is responsible for running and executing that model on the input, right? And that allows it, because it's in hardware, to be done really, really quickly.
Mike, didn't Sora just get released or like recently?
Yeah, Sora was released a month or so ago, and I guess great excitement. And but it depends on. We'd already seen it before, right? We'd seen all the examples. We now are just allowed to use it. Sora's a really interesting one because I think that once we have got our hands on it, we kind of see that it does exactly kind of what we thought it would do, which is that it works pretty well, but also doesn't work a lot of the time and does slightly weird things, that kind of uncanny valley thing where, a dog sort of transforms into a slightly different animal and then sort of defies the laws of physics and something. Yeah. And I think this is entirely expected, right? This is exactly the same thing that we see in the text-based large language models, right? These are actually the same kind of technology underneath. There are differences, but you're still talking about a very, very large model just trained on a lot of data. They still have a problem in kind of grounding their information in the real world, right? There's no physics model that's running. So in a computer game, you have a physics model that defines how your object accelerates. And that at least makes it look semi-realistic, at least depending on the game. Yeah. That doesn't happen in Sora. There's no gravity. There's no concept of gravity. The fact that someone stays on the ground is only because the training data has that happen most of the time. It doesn't stop someone from turning into a bird and flying off, which makes for some pretty cool videos, but also videos that are kind of weird, and I'm not sure I'd actually use them for things. So,
Mike, the biggest concern I think for a lot of people is I'm going to lose my job. AI is going to replace me. Is that true? Do you see that happening? I mean, I have heard instances where some jobs have been taken or companies are trying to replace humans with AI.
I think there's always going to be a desire for companies to try and streamline and save money. Right? Yeah. That's kind of almost by definition what they do. And that's because there's more money to be made that way. Yeah. In actual fact, I suppose people have to reflect on what is it that they do in their job, and can they currently foresee an AI replacing those things, right? So, for example, in my job, I might write some boilerplate code, and I could probably see Copilot or something replacing that aspect of my work at some point. That's actually only a very small part of what I do. there are lots of other things like writing formal documentation that I don't think ChatGPT does anywhere near as well as I can do, because it writes very differently. And so I think that I can't see ChatGPT coming, or any of these models coming close to what I do as a whole. There are maybe some kind of administrative tasks that could be made more easy or streamlined away by using some of this AI. But actually, I don't think it's realistic to say we're going to be replacing huge swathes of the workforce. I think what we might be doing is getting, marginal efficiency gains. I mean, I think Google recently predicted that they think that AI could be by 2030 saving people 100 hours a year.
Okay.
Well, that's great, right?
Yeah.
But I'm contractually obliged to work 1,500 hours a year. So unfortunately, I'm still going to have to turn up.
Yeah.
So I think that companies are going to try and streamline, and sometimes they're going to make mistakes. They're going to replace a bunch of people with a chatbot that then is accidentally a racist, and then they completely embarrass themselves.
Yeah.
And those companies will learn that mistake pretty quickly, I think. I still think we as humans want humans involved. Right? If I ring a company because I need help, I actually want to speak to a person because I think they might want to help me, right? So actually, I think there's strong reasons to think that humans may still be around for a while longer.
So you don't think, like the Nvidia CEO said, that we won't need developers anymore? You don't think that's going to happen anytime soon?
I mean, Nvidia has plenty of developers that they haven't laid off, right? Yeah. So I suppose I would ask why does he feel that Nvidia needs their developers but no one else does? Is it because he thinks that Nvidia developers are better? I don't know. Maybe they are, maybe they're not. I don't see that happening. I've actually met with a lot of developers quite recently at different events, and I think the consensus has been that, when these models came out, there was an immediate reaction of, oh, crikey, they can do quite well.
Yeah.
Is this a problem? But over time and using them, some people don't use them, some people build them into their workflows, but no one, I think, is realistically replacing themselves with one of these models, because I just don't think they do that end-to-end process of all the different aspects of software development all at once. You can try, but I just don't think we're there. Someone said to me, and it was a fantastic point, which is a very quick way of getting legacy code, right? But you can't understand, is to get AI to generate it. Because if you don't have ownership of that code, if you haven't written it yourself, how can you possibly debug it or come back to it in 6 months' time and fix an issue?
Yeah.
So I think that in software development, for example, I think we're going to be around again for a while longer.
I mean, all the cynics would say that there's a reason that Nvidia say that, and that's to push the stock price up.
Yeah, I mean, Nvidia's stock price is primarily now tied to their GPU offerings, right? And their GPUs are bought by about 4 companies, mostly. My own GPU that I have, which is an Nvidia, is not the reason that one card is not the reason that Nvidia has a high stock price.
Yep.
And so I guess it'd be really interesting to see what happens. Nvidia and OpenAI and all of these companies are pushing AI really hard, and it's because they want to be seen to be the ones that are pioneering this, and it is affecting their stock price, right? Nvidia have been, and to their credit, Nvidia have been producing GPUs that can do this number crunching so fast for a number of years. They've been ahead of the game, and that's allowed them to basically completely monopolize the market in terms of the way that we train lots of these models. Will that always be the case? I don't know. Will we always want to train models the size of what we're training now, or will more efficient mechanisms come up? Or will we get bored, right, and decide, this small model's doing just about fine. We don't need the 200 billion parameter model. And if any of those things happen, if the consensus is from the companies, this is big enough, that's when I think Nvidia is going to have to change their strategy, right? And they're going to have to start offering different kinds of products. Just assuming these companies are going to continually buy 100,000 GPUs, 200,000 GPUs at tens of £1,000s a piece is not necessarily a long-term strategy that's going to hold for many years to come. We cannot predict that.
It's interesting because I saw the Devin announcement where they were having this like AI that was writing and debugging its own code and doing everything. And that was like a lot of hype, it sounded like. But it was that whole thing like developers are going to get replaced fully by AI.
I mean, it's a nice idea, but I don't think it's going to work. Right? I mean, I saw there's a GitHub repo, I forget what it's called, where they're trying to replace every aspect of the software development pipeline. So they've got the software development AI, there's the project manager AI, and the senior developer AI and the junior developer AI. I don't know what the difference between those two things is. It's just one they didn't train for as long, right? I can see why they're trying to do this. It's kind of fun as well. But actually, I don't think a lot of what software development is the actual writing of code. I mean, I remember Elon Musk joined Twitter and renamed it, and then he fired most of his workforce.
Yeah.
And there was a rumor, and I don't know whether it's true or not, that they were letting people go based on how many lines of code they wrote. If you talk to an actual software developer, we'll know that number of lines of code is not indicative of code quality. If anything, it's inversely proportional to code quality. Right? It's a bit naive to think that we can just, because of this thing writes code so fast, that must make it better. I think is an interesting way to go, but I don't think it's true.
Mike, I really want to thank you for sharing, and giving us perspective, because there's so much hype, so much noise out there. And I really appreciate you, being willing to come on and share your perspective on all of these things. As you know,
I mostly like to do online videos because I just like telling people about computers. And I think this is one of those times where the hype around AI and the momentum, and not all of it's bad, right? Some of it's hype because the performance is so good. It's nice to be able to take a step and just reflect on some of these things and say, well, which of these things is going to be transformative and which of these things can we broadly ignore and not worry about? And I think also when something moves as fast as AI does, it can be very intimidating for someone who's trying to take it on, or someone who has maybe not been doing this for a year and now they're starting to panic. But actually, I think that's kind of working to our benefit in a way, because there are these new libraries that are coming out where everyone's just learning them for the first time, even people who've been working in AI for a number of years. And so actually, we're kind of all in the same boat.
Mike, I really hope that we can convince you at some point to create your own YouTube channel or create a course so that you can share with all of us.
It's on my mind. I think that there are loads of training courses out there. But as you know, a lot of my videos are kind of just put out there, and if people like them, that's great. And I do think some sort of fundamental how stuff works, especially with AI, could be something I'd think about. So watch this space.
So for everyone who's watching, put comments below. We're going to have a vote. We've got to get Mike to create content. Mike, thanks so much.